Okay, over to you.
Good morning, everyone. My talk is the effects of iron titanium oxide crystallization on the expulsion of interstitial liquid from crystal mush in layer intrusions. The layer intrusion in my study is not so famous, but the magma processes I think is interesting. Okay. Many famous layer intrusion in the world are iron, titanium, vanadium mineralized with different scales, and the relationships of the iron, titanium oxide ores and the cumulates. Okay.
My glasses.
And the relationships of the iron titanium oxide ores with the cumulates are different distinct in different layer intrusions, such as the sharp contact in the Bushfield complex and the Panjirhua layer intrusion in China. In contrast, in the Hongge layer intrusion, the transitional contact occurs varying from net textured ore via disseminated ore to the ultramafic rocks. So the distinct relationship between the iron titanium oxide ores and the cumulates may result in the debate on the formation of their formations. So given that the iron titanium oxides generally occur as interstitial phases in barren rocks and disseminated ores, so the compositional exchange of the main magma body and the interstitial liquid may have thought to be closely related to the formation of the iron titanium oxide ores. The compositional exchange is thought to be controlled by the expulsion mechanism of interstitial liquid. Compositional convection and compaction is thought to be the two mechanisms for the expulsion of interstitial liquid. However, it still remains controversy when each process may play a crucial role. And another important question is how to identify the expulsion mechanism of interstitial liquid. During the solidification of layer intrusion, diverse textures developed. So the quantitative analysis of texture, such as the crystal size distribution, can be used to identify the processes in magma chamber. Okay, a number of ultramafic intrusions occur in the central China. In the northeast of the Hannan Arc, the Bijigo intrusion has an exposed area of 500 square kilometers and 5,000 meters in thickness. This intrusion is iron, titanium, vanadium mineralized with 3 iron titanium oxide ore layers, and it can be divided from the base upwards into the breccia zone, lower zone, middle zone, and upper zone. The breccia zone is composed of gabbro with abundant breccia of country rocks, and the lower zone is composed of pyrrhotite and pyroxenite. The middle zone is composed of gabbro and can be further divided into MZA and MZB. MZA comprises coarse-grained gabbros with rare iron titanium oxides, and MZB comprises fine to medium-grained gabbro with 3 iron titanium oxide ore layers, making up the iron titanium oxide rich segment in the MZB, and the upper zone is composed of diorite. Iron titanium oxide ore layers generally occur in the Cujiaping, Zhoujiabian, and the Bijigo villages in the northeast of the intrusion. We collected samples from a 668-meter long drill hole in the Zhoujiabian village. In this profile, MDAB is composed from the base upward iron titanium oxide ore layer, a chalcolite unit, an oxide gabbro unit, and an apatite oxide gabbro norite unit. Magnetite and ilmenite in the MZB in the iron titanium oxide ore layer are as high as 50%, and the mode of iron titanium oxides are low in chalcolite unit and increase at the bottom of the oxide gabbro unit, with a gradual decrease to the top of the apatite oxide gabbro norite unit. Pyroxene and plagioclase modes in the profile show no distinct variation, except the very low pyroxene mode in the lower part of the chalcolite unit. And fluoroapatite only occurs in the apatite oxide gabbro norite unit. So in order to identify the expulsion mechanism of the interstitial liquid, we carried on the measurement of crystal size distributions for minerals for each unit, such as plagioclase, clinopyroxene, and fluoroapatite. And also, we calculate the fraction of trapped liquid in each unit. Trapped liquid is the miles trapped by the cumulus crystals in the interstices of cumulus crystals due to the accumulation. So we observed the localized alignment of plagioclase around the olivine grains, and they show macro lamination, and cumulus plagioclase are surrounded by the well-formed small nucleus of plagioclase less than 0.5 millimeter. So they are considered to be results from the prior solution compaction by previous studies. Also, we analyzed the CST curves for plagioclase and clinopyroxene in this unit. The curves overall, is overall parallel with a gentle slope for small grains, similar to the curve for the prior solution as in the top right corner of the insight. So we propose that the interstitial liquid in this unit is expelled by the prior solution compaction. Late stage magmatic macrostructures such as the replacive symplectites are pervasive in the iron titanium oxide ore layers. There are two types of replacive symplectites. Type 1 is rotated to magnetite, and type 2 is rotated to olivine. Replacive symplectites adjacent to the root mineral are composed of affable and hertznite, whereas those away from the root mineral are composed of affable and A-enriched plagioclase. So affable and hertznite in replacive symplectites suggest an aluminum enrichment of iron-rich liquid, and I think this is resulted from the involvement of materials from partial dissolution of plagioclase due to prior solution compaction. So Prior solution compaction can change the composition of interstitial liquid, and the cumulus olivine and plagioclase and the interstitial cyanopyroxene in the chocolate unit is show no distinct deformation, and the CST curves for plagioclase is overall parallel, similar to that of mechanical compaction. So the interstitial liquid in this unit is expelled by mechanical compaction. And the CST curves for cyanopyroxene in the oxide gabbro unit show a counterclockwise rotation and a gentle slope for small grains, similar to that for textural porcelain. Textural porcelain can modify the initial CST curves, and so these curves cannot be used to identify the expulsion mechanism. So we model the compaction rates and accumulation rate. The results show that when the compacting layer thickness is higher than 12 meters, the compaction rate would exceed the accumulation rate. Given that the oxide gabbro unit is 153 meters long, so it is much more thicker than 12 meters. So we think compaction would operate. So the interstitial liquid in this unit is expelled by mechanical compaction. We analyzed the CST curves for fluoroapatite. The curves show a concave up, similar to that for compositional convection, with a steep slope for the small grains and gentle slope for large grains. So compositional convection prevails after the abundant crystallization of iron titanium oxides.
1 minute.
Okay. Based on our work on CST curves and modeling, we think that the prior solution compaction can expel the interstitial liquid in the iron titanium oxide ore layers. And after the decrease of iron titanium oxide mode, mechanical compaction operates. And after the abundant crystallization of iron titanium oxides, compositional convection prevails. Fraction of trapped liquid can be used to measure the degree of interstitial degree of expulsion of interstitial liquid. So the results show that low FTL in the iron titanium oxide ore layer, and the FTL value increase with the decreasing mode of iron titanium oxides in the rocks. So crystallization of large amounts of iron titanium oxides can effectively expel the interstitial liquid. So we draw some conclusions based on our work. The expulsion mechanism of interstitial liquid can change from prior solution compaction via mechanical compaction to a compositional convection, depending on the amounts of iron titanium oxides crystallized from the interstitial liquid. And also, the composition of interstitial liquid can be intensively modified by prior solution compaction. Last, CSTs can be used to identify the expulsion mechanism of interstitial liquid. That's all. Thank you.
Very, very quickly, Marian.
Could you just put up your slide that showed the symplectites?
Okay.
So your type 2 symplectites, this olivine with a rim of OPX, then amphibole and spinel, adjacent to plagioclase. This is absolutely typical of coronitic metagabbros, which are gabbros that intruded into the crust during orogenies. So the classic locality for this is in Norway, in the Klemenites of Norway. And so this is a primary sort of almost on the transition between igneous and metamorphic processes. This is a primary gabbro being metamorphosed in the amphibolite fascies. It's actually a subsolidus or just subliquidus metamorphic reaction.
No, we analyzed the composition of the plagioclase in the symplectites. The AN for this plagioclase is as high as 94.
Yeah.
And another important thing is we analyzed, we calculated the formation temperature of the replacive symplectites. The results show that the temperature is above 850 degrees.
Yeah.
Yes. Yes. So I think it's igneous.
It would be very interesting if you
Yeah.
compared them to the coronitic metagabbros
Yeah.
from Norway to see if they're, because
Yeah.
that
Yeah.
sequence of mineral assemblage is exactly the same.
Yeah.
See what they're.
Yeah.
Okay, thank you.
Okay.